Here I have factorial equation and I have to solve for x in this factorial equation. Okay, in this factorial equation, these two fractions have the same denominator, x factorial. But one fraction we have on the left side and another fraction we have on the right side. If I have these two fractions on the same side of the equation, I can simplify them easily because they have the same denominator, x factorial. So for that, what I'm going to do is I'm going to get rid of this fraction over here on the left side. For that, I have to add 13 over x factorial on both sides. Okay, let me do it. So when I add 13 over x factor to both sides, this one and this one will cancel out. I'm getting x over x negative 1 factorial equals to x negative 1 over x factorial positive 13 over x factorial I'm getting over here. Okay, now let me write the stuff on the left side as it is. It is x over x negative 1 factorial equals to, on the right side, we have the same denominator, x factor, x factorial. So when we have two fractions, when we have the same denominator, we can take the denominator once and we have to add the numerators, that is x negative 1 positive 13. So then I'm getting x over x negative 1 factorial equals to, when I combine this negative 1 and positive 13, I'm getting x positive 12 over x factorial. Okay, now to get rid of the x factorial over here, what I'm going to do is I'm going to multiply both sides of this equation by x factorial. So when I do so, this x factor will cancel out and I'm getting x factorial times x over x negative 1 factorial equals to x positive 12. Okay, for example, if I want to evaluate, let's say I want to evaluate 7 factorial, what should I do? I have to write all the integers from 7 to 1 in descending order and multiply them. That is 7 times, 6 times, 5 times, 4 times, 3 times, 2 times, 1. So I have written all the integers from 7 to 1 in descending order and multiplied them all. So this is how we have to evaluate a factorial. In case, instead of expanding this number series up to 1, so in case if I stop at anywhere in the middle, for example, when I expand 7 factorial, I start writing the integers from 7 to 1 in descending order. So I just stop at 4. In case if I stop at anywhere in the middle in the expansion of a factorial, I have to put factor over there so that people can understand it continues up to 1. So the same logic we can apply for this x factor over here. In case if I want to evaluate x factor, what should I do? I have to write first x. So when I want to evaluate 7 factor, what did I do? First I write 7. Then the next number has to be 1 less than the first number 7. The same logic over here. So here I have written whatever number we have here, the same number I have written over here. The next number has to be 1 less than this number, that is nothing but x negative 1. Then the next number has to be 1 less than this one, that is x negative 2. Because when I write the third number, this is 1 less than the previous number, the same logic. So when I write the third number over here, it has to be 1 less than the previous number. So I have to continue this up to 1. In case if I stop at anywhere in the middle, I said I have to put factor over there so that people understand it will continue up to 1. Okay, in this case, in the expansion of this x factor, I just stop in the middle, particularly at the term x negative 1. So since I stop over here, I have to put factorial. So whenever I expand a factorial, I have to continue up to 1. In case I stop at anywhere in the middle, I must take factor over there. Okay, so there is a reason why I stop particularly at x negative 1 factorial, because there is x negative 1 factorial in denominator over here. Okay, now let me continue over here. Now I got the expansion of this x factorial as x times x negative 1 factorial. So I can plug in this stuff for x factor over here. Then I'm getting x times x negative 1 factorial times x over x negative 1 factorial equals to x positive 12. So this x negative 1 factor, x negative 1 factor will cancel out. When I multiply this x and x, I'm getting x square equals to x positive 12. Okay, now clearly it's a quadratic equation. To solve this quadratic equation, I have to get it in standard form, that is in the form of ax square, positive bx positive c equals to 0. So that means we have to get everything on the left side. On the right side, it has to be 0. So to make the right side step 0, I have to subtract x from both sides, and also I have to subtract 12 from both sides. So when I do so, this negative x, positive x will cancel out, positive 12, negative will cancel out. I'm getting x square, negative x, negative 12 equals to 0. Okay, now let me write the equation over here, x square, negative x, negative 12 equals to 0. Okay, now I have to solve this quadratic equation for x, because according to the question, we have to solve for x. That is, we have to find the value of x. Okay, I think this quadratic equation can be solved by factoring. So for that, I have to multiply this constant term by the coefficient of x square over here. So actually, we don't find any number in front of x square. We have to assume there is 1. So when I multiply this constant term, negative 12, by the coefficient of x square 1, I am getting negative 12. So now I have to get two factors for this negative 12. so that the product of the two factors equals to negative 12 and the sum of the two factors equals to the coefficient of x. Here it is negative 1. So I think negative 4 and positive 3 will work. When I multiply negative 4 and positive 3, I'm getting negative 12 because negative times positive is negative, 4 times 3 is 12. When I add negative 4 and positive 3, I'm getting negative 1, which is the quotient of x. Okay, now to get two values for x from these two factors, what I have to do is have to change the signs of these two factors. Already it is negative 4, so when I change the sign over here, it will become positive 4. So the first value of x in this quadratic equation is positive 4. To get the second value of x, I just have to change the sign of this factor. Already it's positive. If I change the sign, it will become negative. Okay, now I got two values for x. One is positive 4 and the other one is negative 3. Okay, now since it's a factorial equation, I have to verify whether both the solutions will work or only one of the values of x will work. So here we have x factorial here and here. So what if I take negative 3 for x, then x factorial is equal to, let me write over here. So if x is equal to negative 3, then it will become negative 3 factorial. So actually a negative factorial cannot be applied for negative numbers. So the factorial can always be applied only for whole numbers. I mean, so for the numbers 0, 1, 2, 3, 4. That is 0 and all positive integers. So factorial can never be applied for negative integers. So negative 3 will not work because here we have x factorial. Negative 3, if I take x equals to negative 3, it will become negative 3 factorial, negative 3 factorial. So it's meaningless. So can I take x equals to 4? Yeah, that's possible because in x factorial, if I plug in x equals to 4, it will become 4 factorial. And also one more check we can do. Here we have x negative 1 factorial. So what if I plug in x is equal to 4? I mean, let me write x negative 1 factorial. If I plug in x equals to 4 over here, it will become 4 negative 1 factorial. That is 3 factorial. This is meaningful. So negative 3, the negative value can be rejected for the reasons what I've explained so far. So we can consider only the value 4 for x. So in the given equation, the value of x is 4.